In this short video, we are going to look at the use of direct attached cables, also known as DACs, to connect Ethernet switches together. If you look closely at a modern Ethernet enterprise class switch, you will notice that in addition to the traditional Ethernet RJ45 copper ports, most switches now have fiber Ethernet ports. These ports are designed to support Ethernet over fiber optics, which is an alternative to traditional Ethernet over twisted pair cables. Ethernet on twisted pair can achieve speeds up to 10 gigabit per second and distance up to 100 meters. However, Ethernet over fiber optics supports significantly faster speeds with up to 100 gigabit per second and a much longer distance of up to 80 kilometers. Fiber ports are designed to receive a module called a transceiver. Depending on the port speed, there are different types of transceivers. The SFP transceiver form factor supports speeds of 1, 10, and 25 gigabit per second. The slightly larger QSFP transceiver supports speeds of 40 and 100 gigabit per second. Fiber ports are used to create high-speed connections between switches. A few switches, like the Ruckus ICX switches, support stacking using standard Ethernet fiber ports rather than proprietary copper ports and cables. Direct attached cables are a less expensive alternative to transceivers plus optics for short-distance high-speed links. With direct attached cables, the transceivers and the cable are permanently attached in a single, easy-to-deploy and maintenance-free unit. Direct attached cables can be installed in the same fiber ports as optical transceivers, and just like transceivers, they come in different form factors. The SFP to SFP form factor supports speeds of 1, 10, and 25 gigabit per second, while the QSFP to QSFP form factor offers speeds of 40 and 100 gigabit per second. Direct attached cables are typically used for high-speed Ethernet links between switches in close proximity, just like switches within the same rack or the same row in a data center or a wiring closet. With switches such as Ruckus ICX, which can stack on standard fiber ports, direct attached cables can be used as stacking cables. There are different types of direct attached cables to support a range of different deployment scenarios and use cases. Passive copper cables are the simplest of all. The transceiver-shaped connectors are directly soldered to the cables without any active component in the system. As a result, passive copper cables are the most affordable even though they offer the shortest distance. Ruckus recommends the use of passive copper cables for links between Ruckus switches up to 3 meters. These cables should be used for stacking Ruckus switches together within a rack or across nearby racks. Active copper cables include active components in the transceivers on each end of the cable. This enables active copper cables to deliver a stronger signal and to support longer distances. However, they do cost more than their passive counterparts. Ruckus recommends the use of active copper cables for links between Ruckus ICX switches over 3 meters and up to 5 meters. These cables should be used for stacking together Ruckus switches separated by more than 3 meters and up to 5 meters. They should also be used for links up to 5 meters between Ruckus switches and third-party equipment such as switches or servers. Active optical cables include active components for the transmission of data over fiber optics. These cables can reach even greater distances of up to 10 meters. You should use them for links between 2 Ruckus switches and for links between Ruckus switches and third-party equipment over a distance of up to 10 meters. Finally, there are direct attached cables that can split a 40 gigabit Ethernet port into 4 10 gigabit Ethernet ports. They come in active copper cable and active optical cable types that support a distance of up to 5 meters for the active copper version and up to 10 meters for the active optical version. Ruckus offers a broad range of SFP, SFP+, QSFP+, and QSFP28 direct attached cables for Ruckus switches and access points. For more information, please check the Ruckus Optics webpage at ruckuswireless.com/optics.